When we first started the program here at Roblox, there was, a lot of nervousness, of course. When you use the word chaos, people are like, why would we want to do that?
Yes.
So I purposely started out by integrating with a system that already pre-existed at Roblox called squeeze tests. So squeeze
Hmm.
tests basically were a way to, in production, stress a particular service. So you could choose a service, and what you do is you reduce the number of instances slowly for that service. So the idea is that you are increasing slowly the request per second on a per container basis or per instance basis. So we call that a squeeze test, and that like stresses each individual container more and more to kind of see where the breaking point is. Do we see latency spikes, CPU
Hmm.
spikes, memory, any kind of bottlenecks that might occur, maybe thread processing or what have you. So I integrated our chaos engineering product with that first, and we ran squeeze tests, but through the chaos engine. The idea of doing that was I did that on purpose to try to use a type of experiment that people were used to in the company, but just doing it through the chaos engine, just to kind of build that confidence level. Once people were used to that, the next goal was to start running experiments that were on very specific, well known systems and we could really reduce blast radius and really target very succinctly. So that way it was very clear that if something went wrong, it probably wouldn't be a huge deal. So that increased the knob a little bit of inducing chaos, but not so much to where people would get too nervous. So we started doing that. And the goal there was one, to test those systems because these were valid experiments, chaos experiments, but also to, again, increase another level of confidence and introducing chaos engineering slowly into the culture. The goal now is, now that we've introduced it, people are used to it, and it's being used fairly heavily now internally, and which is fantastic. But the goal now is typically hypothesis driven, going back to the proactive and reactive experiments that we talked about. So now we'll choose a service or maybe a piece of infrastructure, and we'll say, okay, well, our hypothesis is that if we increase latency on this database connection, it may cause latency to propagate down this
Hmm.
particular call path for an API, let's say. So we'll actually induce that latency and we'll see what happens, and we'll see if the actual outcome matches our hypothesis. A typical hypothesis driven experimentation,
Yeah.
it works well, and sometimes our hypothesis is correct and we're like, okay, it just affected that API path and that was it. Sometimes it hits another API path that we weren't expecting, and we have to investigate, well, why did that happen? Do we need to do more engineering work into separating those paths a little bit better? Where did they cross? Things like that. So that goes back to the proactive experiments that I was mentioning earlier. And then later on, after that, we mentioned reactive experiments. The reactive experiments are not as much hypothesis driven. They're more like reproduction of an incident driven, right?
Hmm.
So we had an incident that happened. We know most likely what happened to cause that incident, and we come up with action items to fix that. But what we do is we'll try to reproduce that same scenario that happened. And the goal there is to actually validate those action items to make sure that they actually work. Because we've had incidents in the past, before we had our chaos engineering platform, we had incidents in the past where we put action items in place and we thought the action items would
Yeah.
fix that particular type of incident, but we ended up having the same incident again later. And now with the chaos platform and being able to actually reproduce that same scenario, we can actually validate the action items and
Hmm.
ensure that it's not going to happen again. So that's a huge win.
Absolutely. And also just getting back to the, yeah, I would call it also the expectation driven way. So, I mean, if you start with your expectation, it's way easier to run the experiment and then verify and validate, is my expectation fulfilled or why not? And otherwise, if you start with an experiment, and I have seen it a lot of times where people are just selecting any kind of attack out of a list, let's say shutdown node. Okay, what is the expectation? They just want to see that the node shutdown attack has been executed? No, that's not how you
Right.
improve your system. You really would like to see how your system reacts and what, very important, what is the impact for your customer?